So now just we have talked about the resistance. So first thing, that resistance which is used to limit the value of current in the circuit and how it works obviously. Yeah, so when we say that, so there is a lot of resistance means, so the electron which just leave one terminal find lot of difficulty to reach another terminal. There is heavy traffic, yeah, so you can say like that also. Yeah, because of which he find it's quite little difficult to move to the another end, so it collides again and again with other your ions or the other free electrons, and which will make the things difficult for him. So that's why the resistance gets increased. So this is how we can understand the resistance also. Obviously we know that we will just, the SI unit for the resistance is nothing but your ohm. Yeah, so the electrical resistance, again you can say that you can manufacture the different values for your resistance based on your requirement also. So these are the symbols for your resistors which we can see over here. So there are some fixed also, or there are some variable resistors also, or we can create the resistance from that rheostat also. So this is how the symbols has been mentioned for this resistors. Again the symbol for meters. So we have studied the voltmeter which is used to measure the voltage, again the ammeter which is used to measure the current. So again, so this measurements of resistances, yes, so again the measurement of resistance also we know that I is equals to find V upon R. So for that obviously you have to measure the value of current and voltage through the circuit, and once we got that value we can calculate the value of resistance. So for that we always connect the voltmeter which is in parallel, and we are going to connect your ammeter in series over here, and then with the help of which we will get the value for your current for this particular case. Now there are different factors which are affecting the resistance. So what are those different factors? We will study it one by one. So let's say if I consider a wire, let's say it is a conductor of a particular length. So when we just talk about this length, yeah, so definitely I will say that, so one wire which is of your 10 meter, and then in the second case the one wire which is of 20 meter. Yeah, so this is, let's say 10 meter, this is your 20 meter. So for this case the wire which is having the length of your 20 meter is having more resistance. Why? Obviously the electron which is traveling through this 20 meter wire has to cross so much of large distance, yeah, as compared to the first one. Yeah, so then definitely there is a more collision in the second case as compared to the first, and obviously because of which the resistance of the that wire also gets increased. So obviously we can say that, so this resistance is proportional to the L. Yeah, it is proportional to the L. The more is the length, yeah, so the longer is the wire, obviously the more will be the resistance. So that is what we can say about the length of that here. This is about the length of wire. So if length is more, obviously the resistance is also more. If consider now the next one, that is the area of cross section. So how this area of cross section is going to affect? So this area of cross section, obviously let's say this one I have shown, and this is nothing but the another one. Yeah, so let's say this is another one. The another one is slightly, I have shown that it is a wider one, its cross sectional area is more. Yeah, so this is A2 and this is nothing but your A1. So A2 is greater than that of your A1. So the electron, they are more free. Yeah, so they just can travel easily through this wider cross section. Here there is a lot of, you can say, heavy traffic is there. It's little bit difficult for the electron to travel. Yeah, but in second case, so if the area of cross sectional is greater, so you can say that the resistance is less. There is a less possibility of collision. So definitely if there is a less possibility of collision, means electron can flow easily from one end to the another end. So that's why this is inversely proportional to your area. Yeah, so this is how we can say about this. Again, the nature of material, the number of electrons contained by that your material per unit volume. Yeah, so which decides also the value of your resistance. So in short, I will just write it down, just combining all these things I can write it down. So this is rho L upon A. So this rho, which is called as a, this is the resistivity. Yeah, so this is nothing but what we will call as a resistivity of a material. This is how we will say that it is nothing but the resistivity of a material. So if I want to define that rho is equals to RA upon L, so this is your ohm meter square upon meter. So then definitely this is ohm meter. Yeah, so this is the resistivity. So that is how I can write it down. That is nothing but the ohm meter. Fine. So that is the unit for your resistivity. Also the resistivity for given material, it is fixed. The resistivity is less or minimum for the conductor, it is maximum for your insulator. So that is also in general we can say about this one.